Hey y'all, today is April 20th and we are going over lesson 8-6, area of a circle. So this is just a little mini lesson that you can watch to help you understand better or to catch up on notes if you are on the choir or band trip. So first things first, let's talk about vocab in regards to a circle. We already know that circumference is the distance around a circle. So think of it as the perimeter of the circle, right? Now the radius goes from the edge to the center of the circle. And the diameter goes from one edge to the other edge of a circle. So it goes all the way across. I want you to remember that the diameter is always twice as long as the radius. In other words, the diameter is 2 times the radius. But that means that the radius is always 1/2 of the diameter. In other words, the radius is the diameter divided by 2. Okay? So now that we know that kind of relationship, we've reviewed what the circumference is. Let's talk about what area is. Area of a circle is the amount of space occupied by a circle. Area is the amount of space occupied by a circle. So how much space does it take up? And there is a formula to find area. Our formula to find area is pi times the radius squared. Pi times the radius squared. Now let's talk about pi. Every time we see that, we're going to use the approximation 3.14. And the radius squared means I'm taking the radius and I'm multiplying it times itself. So r times r. Okay, so that is our formula. A equals pi times the radius squared. And of course, we're going to use our calculator to make that easier for us. So now that we've talked about all that, let's jump right into some examples. So in number 1, I have this circle with a radius of 10. So we know our formula, A equals pi times the radius squared. And just to make my life a little bit easier, I'm going to copy that because I'm going to be writing it a lot. Okay? So what can I plug in here? Well, we know for pi, I can use 3.14. And for the radius squared, I'm going to use 10. And I'm going to square that. So the way I'm going to put this into my calculator is I'm going to type 3.14, multiply that times the radius, and then look at that top left button that has a squared. I'm going to hit that button and it's going to square my radius. So now I've got 3.14 times 10 squared, which is 314. So my area for number 1 is 314, and it's centimeters squared. Okay, let's move on to number 2. Again, I'm given a circle that has a radius. So I'm going to use my same formula, A equals, and like I said, I was just going to paste this, pi times the radius squared. So what can I plug in here? Well, A equals 3.14 for pi, and then my radius is 2, and I'm going to square that. So we're going to go back to our calculator. We're going to type 3.14 times 2, and I'm going to hit that A squared button. That's going to square my radius, and I get 12.56. So my area is 12.56, and it's kilometers, but I have to square my units, squared. 12.56 kilometers squared. Okay. Moving on to number 3. This time I've been given a diameter, so I need to know my radius. So keep in mind, if my diameter is 24, my radius is half of that. So my radius is 12. 24 divided by 2 is 12. So that's what I'm going to use in my formula. Remember our formula, A equals pi times the radius squared, right? So A equals 3.14 times my radius, 12, and I'm going to square that. So now I'm ready to go to my calculator and figure out what my area is. So we have 3.14 times 12, that was our radius, and we're going to square that. We get 452.16. So my area is 452.16, and it's centimeters squared. Okay, moving on to number 4. Again, I have a circle where I've been given a diameter, so I need to figure out what my radius is. Well, if my diameter is 50 meters, I know that my radius is half of that, so 50 divided by 2 is 25. Okay, so now that I know that, I'm ready to use my formula. A equals pi times the radius squared. So what can I plug in here? Well, A equals 3.14 times my radius is 25, and I'm going to square that. So now I'm ready to go to my calculator. So 3.14 times 25, that was the radius, and I'm going to square that. I get 1,962.5. So the area is 1,962.5 meters, and don't forget to square your unit. 1,962.5 meters squared is our answer. Okay, moving on to numbers 5 and 6. So these are different because they're both semicircles. And remember, a semicircle is just half of a circle. So I'm going to use my same formula, but I'm going to multiply it times half or divide it by 2. However you want to see it, it's the same thing. So first of all, what I notice in number 5 is I've been given this distance here. Well, that's my diameter. So if my diameter is 3, what is my radius? Well, my radius is half of that, so my radius is 1.5. 3 divided by 2 is 1.5. Okay, now that radius is important because that's what I'm going to use in my formula. So remember our formula, A equals, and it's normally pi times the radius squared, right? But I need to multiply that times 1/2. So, because I just have half of a circle, right? So what can I plug in here? Well, A equals 1/2 times 3.14 times my radius, we already said was 1.5, and I need to square that radius. So I'm going to plug this into my calculator. Now the only difference is I'm going to use 0.5 when I put that into my calculator. Okay, so let's go to my calculator. So we have 0.5 times 3.14 times the radius, 1.5, that I need to square. So I've done everything, plugged everything in, and I get 3.5325. So my area, change that back to a pen. Area is 3.5325 feet squared. Okay, moving on to number 6. Again, I have a semicircle. So my formula is the formula for area, but I'm going to multiply it times 1/2. Or in other words, I'm dividing it by 2 because we just have half of a circle. So I'm just going to put a 1/2 out in front, right? Now, this time I was given the radius, so that's good. So area is 1/2 times 3.14 for pi times 5.2, and I need to square that. So now I'm ready to put this into my calculator. So we're going to use 0.5 for 1/2 times 3.14, that's my pi, times my radius was 5.2, but I have to square that, and I get 42.4528. So area equals 42.4528, and it's feet squared. Okay, moving on to our next page. So this time we have some word problems. So number 7 says the maximum distance that a light on a lighthouse can reach is 20 miles. If the light can rotate 360 degrees, find the total area that it can light. Okay, so first of all, when I see that the light can rotate 360 degrees, that means it's going in a circular pattern. So we have a circle, right? And I know that my lighthouse is in the middle. So the lighthouse is right there. So if the light shines in any direction, it's reaching 20 miles. Okay, it says that right there, 20 miles. Now we're asked to find the total area that it can light. Well, 20 miles is my radius. So I'm just going to use my area formula. So area equals pi times the radius squared, right? So what can I plug in here? Well, area equals 3.14 times 20, and I need to square that 20. So now I'm just going to put this into my calculator. So we have 3.14 times 20, and I'm going to square that 20, and I get 1,256. So the area is 1,256 miles squared. That's how far that lighthouse light can reach. Okay, let's look at number 8. It says Mrs. Vickers is covering her student work table with chalkboard paper. The table has a radius of 3.8 feet. How much paper will she need? Okay, again, I like to start with a drawing just so I know what I'm talking about. So that's the circular table, and it says that the table has a radius of 3.8 feet. So I know that that means it goes from the outside edge to the center. So 3.8, right? So I'm just going to use the area formula. So area equals pi times the radius squared. So I'm going to start plugging some stuff in. So area equals 3.14 for pi. My radius is 3.8, and I need to square that. So I'm just going to put this into my calculator. So 3.14 times 3.8, and I have to square that, and I get 45.3416. So the area equals 45.3416 feet squared. Okay, moving on to number 9. The Roberts family is getting an in-ground circular pool with a radius of 9 feet. The company needs to dig out an extra 3 feet all the way around the pool to have enough room for plumbing. What is the area of the grass that will be removed? Okay, so first of all, they're getting a circular pool, which sounds so lovely. And the radius of that pool from the outside edge to the center is going to be 9 feet, right? Yes, radius of 9 feet for the pool. But the company needs to dig out an extra 3 feet all the way around the pool to have enough room for plumbing. So that means they're actually going to make a bigger circle, right? And I know that it's going to be 3 feet all the way around. So there's going to be an extra 3 feet here. So what is the actual radius that will be dug out? Well, 9 plus 3 is 12. So my actual radius of the grass that will be removed is 12 feet, right? So now that we know that, we can use our area formula. Area equals pi times the radius squared. So I can start plugging some stuff in. Area equals 3.14 times 12, and we're going to square that. So let's take that to our calculator. So we have 3.14 times 12 and square that 12, and we get 452.16. So the area equals 452.16 square feet, or feet squared. Okay, last one, number 10. Bob needs to buy a cover for his above ground pool. The pool is in the shape of a circle and has a diameter of 18 feet. Pool covers cost 75 cents per square foot. How much should Bob expect to spend on a pool cover? Okay, so I always like to draw a diagram. That's our circular pool, and we know it has a diameter of 18 feet. So from one edge to the other edge is 18. Well, diameter doesn't help me a whole lot in my area formula. I need the radius. So if the diameter is 18, what is my radius? My radius is half of that. 18 divided by 2 is 9. So we're going to use that value for my radius in my formula. So area equals pi times the radius squared, right? So let's plug some stuff in. Area equals 3.14 times 9, and I need to square that 9. Let's take that to our calculator. So 3.14 times 9, square that 9, and I get 254.34. So the area is 254.34 square feet, right? Now, that's not our answer because we want to know how much should he expect to spend on the pool cover. We know that the cover costs 75 cents per square foot, and we know the amount of square feet, right? So I'm just going to multiply those two values together. So I'm multiplying this value with that value. So 254.34 times 0.75. And we're going to put that into our calculator. So I'm going to get back to my Desmos calculator here. I'm going to get a new line. And I'm going to hit this ANS button. That means answer, my previous answer. So 254.34 times 0.75, 75 cents per square foot. And I get this number right there, 190.755. But I know that money only has 2 decimal places. So I need to cut it off after the second decimal place, right? So because my last decimal place, the third one, is a 5, I'm going to round up. So 190.76 is about how much he would expect to pay. So oops, I don't know what just happened there. We're expecting that he will pay $190.76. And that right there is our answer. And that is the end of this little mini lesson on area of a circle. Y'all have a great day.